Good morning, students. I am M. Venkataya, Assistant Professor in the Department of Mechanical Engineering at Vignas Lara Institute of Technology and Science. Now I am going to teach the subject is thermal and hydro prime movers. So this is the last topic of fourth unit, that is impulse momentum equation. That is the fixed and moving plates. So this is already I have explained in the previous classes. That is the impulse momentum equation, impact of jets on stationary and moving vanes, flat and curved. These are already completed in the previous classes. Then today's class already explained in this pumps, different types of pumps. So the main components, the working principle, multi-stage pumps, performance and characteristics curves. Okay. So in this class, what I have discussed is the centrifugal pumps, the main components, centrifugal pumps, main components and working principle of centrifugal forces, centrifugal pump and multi-stage pumps, performance and characteristics curves. Okay. In this, first of all, the centrifugal pumps. So what is centrifugal pump? So what is meant by centrifugal pump and the working mechanism of a centrifugal pump and advantages and disadvantages of centrifugal pump. This is the last topic of fourth unit. Okay. So first of all, what is meant by centrifugal pump? So see here, this is the centrifugal pump. So here convert the mechanical energy into hydraulic energy by centrifugal force on the liquids. Okay, so see here, we are using in the cultivation purpose. So the canal, the flow of water is in the canal. So we want to cultivation process, the mechanical energy will convert to the hydraulic energy. Then it's called the centrifugal force or centrifugal pumps. The main concept of the centrifugal pump is to utilize the water of from the water is canal, the flow of water from canal to the cultivation. So cultivation purpose we are using the centrifugal pump. So see here, the convert the mechanical energy. So here the convert the mechanical energy into hydraulic energy by centrifugal force on the liquid. So here see, here the main thing is to convert the mechanical energy into hydraulic energy by centrifugal force on the liquid. Okay, this is the main important point. Okay, then the constitute the most common type of pumping machinery. Okay, so here the most common type of pumping machinery used to move liquids through a piping system. So use it to move liquids. So use it to move use it to move liquids through a pumping system. So if you take the water pumping system, or if you take any oil pumping system, so we have to see here, this is the suction nozzle, we have to see here, this is the suction nozzle and the seal, yellow color represents the seal, and the shaft oil rings, this is the shaft oil rings, the totally centrifugal pump. So this is the overall diagram and the components of the centrifugal pump, that is the impeller and valve and the casing and the discharge nozzle. This is the discharge nozzle. Okay, and coming to this one is the bearings. This one is the bearing. So see here, this is the discharge nozzle and this one is the shaft and the bearing housing. This is and the seal glads. Okay, suction nozzle. This is the suction nozzle and seal flush line. See, flush line. So here we see here in the constitute the most common type of pumping machinery used to move liquids through a piping system. Used to move liquids. So either water or oils through a pumping system. Okay, and it has two main components. So it has two main components will be there. The two components is so used to move liquids through a pumping system. Already tell about in this previous slide. So that it has two main components. The two main components is stationary stationary components, casing, casting, cover and bearing. Okay, so first one is stationary components, casing, cover and bearings. Then the second point is the rotating components, impeller and shaft. So impeller and shaft, it will be a rotating components. Okay, that is the rotating components. That is one is the impeller and shaft. Okay, and classified into three categories. So it is classified into three categories. That three categories is, first one is radial flow type of centrifugal pumps, and second one is mixed flow. Third one is axial flow. Third one is axial flow type of centrifugal pumps. Okay, see once again. This is the classified into three categories. Okay, so the centrifugal pumps classified into three categories. One is radial flow, second one is mixed flow, third one is axial flow type of centrifugal pumps. And coming to the simple mechanism, that is the mechanism of a centrifugal pump. So we have to see here. This is the first of all I want to explain some of the working principle of. So we have to see here. This is the impeller. Okay, and this valve is suction eye. This is the suction eye. This is the suction eye. And the volute, this is the volute casing. This one is veins. Okay, then this one is discharge. This one is discharge. Okay, so first simplest price of equipment in any process plants. Okay, any process simplest piece of equipment in any process plant. And energy changes occur by virtue of impeller and volute. Okay, liquid flow path inside centrifugal pump. So we have to see the in this diagram. This is the we have to see in this part, that is the belongs to only for that particular suction eye part. Okay, and this is the volute casing, volute casing, and this one is the impeller and suction. This is the suction eye and the veins. This is the discharge. This one is belongs to only for discharge. So centrifugal pump, the working mechanism or working principle of centrifugal pump, we have to see. Liquid is feed into the pump. First of all, the liquid, where it is using the liquid, that is oils or water, whatever it is, that is the liquid. If you take the water, water liquid. If you take the oils, oil liquid. So fuel. So fuel is feed into the fuel or liquid is feed into the pump at the center of a rotating impeller and thrown outward by centrifugal force, and thrown outward by the centrifugal force. So centrifugal force. The conversion of kinetic energy into pressure energy. Pressure energy supplies the pressure difference between the suction side and delivery side of the pump. So here what we are observing is here the liquid is feed into the pump. Okay, whenever the liquid is feed into the pump at the center of a rotating impeller, at the center of the rotating impeller. So this is the impeller at the center of the rotating impeller. Rotating impeller and thrown towards by centrifugal, thrown towards the centrifugal force, thrown towards the centrifugal force. The conversion of kinetic energy to, so the conversion will start from kinetic energy to pressure energy. So kinetic energy to the conversion of kinetic energy into pressure energy supplies the pressure difference between the suction side and delivery side of the pump. Suction side and the delivery side of the pump. That is the main important role of this working principle of the working principle of centrifugal pump. And coming to the advantages of centrifugal pump. So the main advantages of centrifugal pump is simple in construction and cheap. Okay, simple in construction and it is a very cheap. It is a very cost point of view. It is a very cheap and handle liquids with large amount of solids. Okay, handle liquids with large amount of solids. No metal to metal fits. Okay, no metal to metal fits. No walls involved in the pump operation. So no wall involved in pump operation. Maintenance cost are lower. So the cost point of view or few of the good advantages regarding that centrifugal pump is to simple in construction and cheap. It is a very cheap cost. And handle liquid with a large amount of solids, no metal to metal fits, no walls involved in pump operation. Then the maintenance cost are very lower. The maintenance cost is very lower. So that's why these are the better option for pumping system. We are using the centrifugal pumps. So some of the disadvantages of centrifugal pump. So cannot handle highly viscous fluids efficiently. So cannot handle highly viscous fluids efficiently. Okay, then cannot be operate at high heads. So it cannot be operates the high head turbines, high head values, high head valves and high head levels. maximum efficiency holds over a narrow range of conditions. So it is some of the disadvantages will be there occur in this particular centrifugal pump. That is the maximum efficiency holds over a narrow range of conditions. Over a narrow range of conditions. So the cavitation pumping problems, we see the we see the pumping problems, so that the cavitation reduces the pump capacity, causes metal removal, reduced flow, so reduces the pump capacity. That is pumping problem. First thing is here the pumping problem, so we have to take that cavitation, so reduces the pump capacity. First of all, reduce the pump capacity. How much will be there in that particular pump? Okay, so pump capacity causes metal removal and reduced flow. Okay, loss in efficiency or noise to avoid the cavitation, NPSH. Okay, so NPSH is nothing but the GC, that is the formula. NPSH equal to GC by G into pressure of A minus pressure of V by rho minus HFS. This is the formula, minus ZA. Okay, so this is the power. Coming to the power and efficiency, so this is the calculations. The power supplied to the pump, we have to see here. That is the power supplied to the PB, already written in this previous slide. That is the PB equal to M into delta H by efficiency. So where M is the mass of flow rate, kg per second, and delta H is the total discharge head. So or Newton meter for delta H. Delta H is nothing but the units is Newton meter per kg. Newton meter per kg. And this is the efficiency. Okay, this is clear. Now the power delivered to the fluid. So the power delivered to the fluid, so PF equal to M into delta H. We know that the M value, that is the mass of liquid, the delta H from equation 1 and 2. So this is the equation number 2. This is the equation number 1. Okay, from the equation 1 and 2. From the equation number 1 and 2, then we get the efficiency of the pump, centrifugal pump, is a PF by PV. PF by PV. This is the efficiency of the centrifugal pumps. And the pump selection, the amount of fluid, the properties of the fluid, types of power supply, cost and mechanical efficiency of the pump. So see here is the pump selection. First of all, the amount of fluid. So how much amount will be there in that particular pump and in that particular amount of fluid. Then the power, the properties of the fluid. So the properties of the fluid. So some of the properties of the fluid, if you take the water, so the density value, we know that the density value, that is 1000, and viscous force and the calorific values and the thermal conductivity. Some of the standard fluids is there. That value we have to remember. The properties of the fluid and type of power supply. So which type of power supply we are using, we have to select that particular things. cost and mechanical efficiency of the pump. So cost and mechanical efficiency of the pump. So finally, in this class I have discussed the first thing is what is meant by centrifugal pump. What is meant by centrifugal pump? Okay. Next, the components of centrifugal pump. Components of centrifugal pump. Then the working principle of centrifugal pump. Okay, this is that. And after completion of this fourth unit, then go for the fifth unit, that is turbines and the hydro power. Okay, thank you.